Hey. Can you hear me well? Hello, Bade. Hello, can you hear me well? Can you let me know, please? Hello, hello.
Yes, I can hear you, sir.
Ah, excellent. Excellent. Right, so today we're going to talk about inequalities. The assignment is almost ready. It's I've published a draft version on the whiteboard, so I'll show it to you today so you can have a look. Right. Hello, hello, Bede. Hello, Jerry. Hello, Edward. Hello, Mia. Okay. So I'll start sharing my screen. First, I'll show you the assignment. So you're the first ones to see the assignment. So here it is. It's called Inequalities. And the reason why I've put it here as when I was designing the program is that inequalities are not covered very well in A-levels. Okay, so a few things are not covered very well, but it's such an important thing, inequalities. Somehow the people who designed the A-level program think that it's too complicated. But I will show you today that inequalities are actually super simple. Like, I mean, at least most of them are. Okay. So the first section is rational inequalities, and they're asking to solve inequalities like this. Do you think you can solve this inequality? Do you? Just type in the chat, please. Do you think you can solve this? Okay. Right. Would anyone like to comment? Like anyone who's brave enough to use the microphone? How would you do it?
Would you multiply both sides by 3 minus 2x all squared? Then 3 minus 2x all squared not be negative, so you're not risking the thing. Like you don't. If you just multiply by 3 minus 2x, you don't know whether to flip the inequality sign or not.
Exactly. Yeah, that's one method, and it's actually described here. That's one way of doing it, and you get a quadratic inequality, which is easily solvable. Another way is just to see what do we have here. Well, we have two possibilities. Well, one possibility is that this is a positive number. And if this is a positive number, it has to be bigger than 1. Yeah, because 1 over something is less than 1. If this is positive, that means that 3 minus 2x has to be greater than 1 if it's positive. Or if it's negative, that means any number will suit, because any negative number will be less than 1. Or 3 minus 2x is less than 0. This is another way of doing it. So it's another way of doing the same thing, but in a slightly different way. Okay, so let's have a look at what we have here. So here I have some very simple inequalities. I know you can solve them. I'm sure you can. But I'm just going to show you a method. It's called the method of intervals. And this is the key of today's session, method of intervals. If you sketch a very rough draft of this graph, you will see that this function has two zeros. This is 0 and 2. And between those zeros, the function is either positive or negative. In this case, it is a parabola, which is going like this. And it's positive here, and negative here. So all we need is to write down where it is positive, because it says positive. So we are interested in these two intervals. Sometimes it is not clear how the parabola looks like. So to check the sign, you check any number from the interval. For example, from 2 to infinity, any number. So let's say 4. So 4 multiplied by 4 minus 2. I don't even need to solve it. I see it's positive. It's positive, so here it's going to be positive. Any number between 0 and 2 will yield a negative answer, and any number less than 0 will yield a positive answer. So the answer to this question is x belongs to the interval from minus infinity to 0, union, well, it's, you can say or, from 2 to plus infinity. There's another way of writing it. You can simply say x is less than 0 or x is greater than 2. How well do you understand what I did here? I mean, I know you can solve the inequality, but do you understand what I did here? Look, why I did it like this? On a scale of 0 to 10, please. Okay, lots of 10s. Brilliant, brilliant. Right. But the beautiful thing about this method, that, for example, this inequality is not harder than the one that we just did. That's the beautiful thing about it. So method of intervals. So what the method of intervals require? What does the method of intervals require? You need to identify, so method of intervals. First, identify where the function does not exist. Identify where the function does not exist. 2, identify the critical points. Zeros or discontinuities. 3, identify the function will have constant sign on each interval between critical points. Okay, this is a rough. This is not a this is not a set in stone instruction. We'll just follow this. Of course, there is step 0. Step 0 is write the inequality as f of x is less than 0 or f of x is greater than 0. Basically, what I'm saying is you have to have 0 on the right-hand side. 0, 0 on the right-hand side. Okay, so let's follow this instruction and solve this inequality. Now, identify where the function exists. Well, this function exists for any x. So there are no points where this function does not exist. So that's not a problem. Identify the critical points. The critical points. The critical points is when something interesting happens. Usually when the function is 0. So the critical points is x equals 1 and x equals 3. So I'm going to draw them. Now, this is the x-axis. So I put 1. Now, this is x less than or equal to 0. Therefore, the points will be shaded. X equals 1 and x equals 3. Now, in the previous example, I used non-shaded points, circles, and here I have shaded circles. Now, I need to identify where the function is positive and where it is negative. Well, to do this, I can either look at the function or simply identify. Okay, let's say 4, and I take any number from this interval. 4 minus 1 squared positive, 4 minus 3 positive, so it's going to be positive here. Between 1 and 3, any number, so let's say 2 minus 1 positive, 2 minus 3 negative, so this is going to be a negative value. Any number to the left of 1, so let's say 0. 0 minus 1 squared is positive, 0 minus 3 is negative, so it's going to be negative again. I put the minus on the bottom, and I sketch the function. But because this is a solid point, I'm drawing it like this. Now here it's going to be negative and then negative again. And I'm interested where the function is negative. So the function is negative here. And actually, it's also at point x equals 1, it's 0. So it suits us. So the answer is x in the set from minus infinity, not including, because minus infinity is not a number, up to 3, including. The square bracket means included. Or you can simply say x less than or equal to 3. Yeah, this is an easier way of saying the same thing. Okay, so let's get to this one. So well, one important thing happens here. If we look at this square, this means that this bracket is always non-negative. And that's why the function does not change sign when at 0. So normally you have the critical points and the function changes sign like this. But here, because there's a square, there's no change of sign. There is a 0, but there's no change of sign. You must be familiar with this from cubic. Oh yeah, it could be a semicolon or a comma. It doesn't really matter. From one value to another, from minus infinity to 3. Yeah, so x is any number from minus infinity to 3. Does that make sense? I mean, it's just in different countries they do commas. In some countries, they do semicolon. It doesn't really matter. Okay, I'd stick with the comma. It's more British. Problem 3. Problem 3. So what do we see here? Well, we see a bunch of critical points. 0, 3, -2, 6, 8, -1. What about this one? Oh, perhaps we could factorize it. But probably you're experienced enough to say that. To say what? Help me, please, with this one. I want to factorize it. What would you say about that? It has no roots. So what does it mean in terms of an inequality? In terms of an inequality in being greater than 0, what does it tell you? It's always positive. X squared plus 4x plus 6 is positive for any x. Any x, and this is very important. You can prove that very easily. You can write it like this: plus 2. It's x plus 2 squared plus 2, and it's always a positive number. This is a positive number, and a positive number in the denominator cannot affect whether something is greater or less than 0. This has no effect on the whole function. So we simply forget about it. And we write down the critical points. So critical points are 0, 3, so 0, 3, x equals 3, x equals -2, the x equals 6, x equals 8, x equals -1. And this does not have any critical points because it's never 0. So we draw the critical points. Oh, sorry, we identify the discontinuities, of course. So we say that x is not equal to 6, x is not equal to 8, and x is not equal to -1. Now we draw the points. Now, if x is allowed to be, because there's greater or equal to 0, so we start putting the critical point, 0. 0 is going to be shaded because it's a non-strict inequality and x can be 0. X equals 3, also shaded because x can be 3. -2, also shaded because x can be -2. Now x is 6, so 6 is here, and it's not shaded because x cannot be equal to 6. Also 8, because x cannot be equal to 8, and -1. It cannot be equal to -1 either, so it's like this, -1. Now, we know that the function will change sign at every point except -2. -2, the sign does not change because of this square. We've established this in the previous one. But if you're in doubt, you just check any number from the interval. So check 9. Check 9. Check 9. So it's going to be 9, 9 minus 3, 9 plus 2 squared over 9 minus 6, 9 minus 8, 9 plus 1, and something positive. Positive, 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 positive. So this is a positive. So on this interval, the function is positive. On this interval, you can check 7. You can do it yourself, but it will be negative because the function changes sign. Positive, negative, positive, negative, and negative again, because in the 2, the function does not change. In the -2, the function does not change sign. And now we draw a peculiar line. Hopefully you will appreciate it. Now this is going to be square because the dot is shaded. Bam, bam. Now here we have a square bracket, but then we go down again and continue this way. Right. Now, can I ask again, how well do you understand what I just did? How well do you understand what I just did? It's basically a sketch of the function. The square indicates that it actually crosses, that it is a 0, and the circle indicates that it is a discontinuity. How well do you understand on a scale of 0 to 10, please? Again. Okay. Have you done this before? Can I ask? Has any of, just yes or no, have you done this before? Okay. Good. And now we need the interval which is greater or equal to 0. And we just shade it. 1, 2, and here. And of course, what about this point? Well, it's equal to 0. If we are in doubt, just check. -2. -2 is going to be 0, and it's greater or equal to 0. So -2 is fine. -2 is also an answer. So x can be -2, or it can be anything from -1 to 0, including 0, excluding -1, or from 3 to 6, not including 6, or from 8 to plus infinity, not including. Now, this is where this notation wins, because if you try to write it in the normal notation as you are used to, it's just going to be a mess, because you'll have to say x is -2, or in words x is less than -1 and less. This is much easier to read in a way, at least when you get used to it. Now, I don't want to make you feel bad, but when because I went to a school in Russia, and we did this in year 9. Pretty much exact same question. And this problem 4 is actually, I've just taken it from an entrance exam to a Russian school at year 10. So this question is from an entrance exam into year 10. So right. So what do we do here? Well, we don't have a 0 on the right, so we're going to make it 0. So we are going to say, okay, it's going to be x over 2x squared plus 5x plus 2 minus 1 less than or equal to 0. And then I just make the common denominator. So x minus 2x squared minus 5x minus 2. And 2x squared plus 5x plus 2 less than or equal to 0. This already looks much better. And now, okay, so what do I have here? I'll try to factorize the denominator. Sorry, I'll just cheat a little. 5 using technology. It's going to be 2x plus 1 and x plus 2. Because we don't know whether it's positive or negative. Because if the denominator is negative, there has to be a change of sign. Does it make sense? Like, let's say you have 1 over x is less than 2. Now, if you multiply by x, you get 1 less than 2x. So x is greater than a half. And that's true. Any number which is greater than a half fits. For example, 1/3 is definitely less than 2. 1/10 is definitely less than 2. But a negative number would also fit, and we lost it. Where did we lost all the negative answers, because x can also be any negative number. So that's why you don't, in an inequality, the rule in an inequality, if you don't know whether something is positive or negative, you can't multiply. And here, this is going to be minus 2x squared minus 4x minus 2. Now, of course, it depends on your preference. You can you can still factorize, but what I would do is I would normally multiply by -1 and change the sign. Yeah, I would say 2x squared minus plus 4x plus 2 bracket 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 is greater or equal to 0. Okay, this is what I would normally do. I'll do it slightly differently this time. I am going to take -2 out, -2, and I'm left with x squared plus 2x plus 1. And if you are observant, you will see that less than 0. So -2, this is x plus 1 squared. In fact, if you factorize this, it's x plus 1 squared. You get 2x plus 1, x plus 2, and less than or equal to 0. And now all we need to do is apply the method of intervals. I'll just delete that. So x, and this is going to be critical points is -1, -1. Oh no, don't do it to me, please. minus 1, minus a half. Now, minus a half is not included because x cannot be. X is not equal to minus a half. X is not equal to minus 2. And minus 2, of course. Minus 2. Now, we need to determine the signs. To do this, we check any number that is in this interval. So I'm going to take 0 because that's the easiest number. 0 plus 1, positive, 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 but minus 2 is negative. Minus 2 is negative, so it's going to be negative. It's a negative value. Then the sign changes. Now, yet again, when it's x plus 1 squared, because it's x plus 1 squared, it does not change sign here. And then changes sign again. So we usually do it from right to left. So now the line goes down, square, square, like this. So basically what happens is the graph touches the axis at this point. The graph touches the axis at this point, and we need the negative values. So we need the negative values, these ones, and 1, because when x is, minus 1. So x belongs to the interval from minus infinity to minus 2, not included, or x is minus 1, or x is from minus a half to plus infinity. Okay. And now all the other questions, they're just variations of the same thing. Oh wow, in 30 minutes we went through four questions. That's probably a record. Any questions? I'd like your input, perhaps. Any questions? Something you don't understand here? Is the background noise too loud? It shouldn't be. So what do we have? Like problem 5, I think I might skip problem 5 and get back to it later because it's pretty much the same. It's the same as problem 4. The only difference is you might need to do some clever things with cubes. Actually, yeah, let's do it. We all have a cubic expression, which is not very nice, but we can deal with it. So take everything to the left, 0 on the right, and we have common denominator, of course. So if this is not automatic to you, make it automatic, because this is very important. Dealing with fractions, algebraic fractions, of course, plus 2x minus 2, because I multiply this by x minus 3, I multiply this by x minus 2, and I multiply this by x minus 2, x minus 3. Minus 2 minus x, x minus 2, x minus 3. We don't have a cubic term, which is very lucky, because cubic terms are generally not nice. X minus 3, and this is less than or equal to 0. Then what do? Well, we expand. There's nothing else to do. You never expand the denominator because it's pointless. Oh, sorry, Edward. Yeah, can you tell me which question are you talking about? Sorry, I missed your question. This sequence. So I did write the inequality as this. Yes, this is the first thing that we did. This was the hardest thing. If you can say hardest, like first we write the inequality like this. It has to be less than or equal to 0, and it has to be factorized. The next step is identify the critical points. We've done that. We identified where the function is positive and where it is negative. And we just shaded the regions where it is negative. So it's the same thing here. We took everything to the left-hand side. We found the common denominator. The common denominator is x minus 2, x minus 3. Now we expand the numerator. So x cubed minus 2x squared minus x minus 3x squared plus 6x plus 3 plus 2x minus 4 minus x cubed plus 5x squared and minus 6x. I really hope I didn't make a mistake. Okay. X minus 2, x minus 3, less than or equal to 0. And look at that. Our cubic term disappears. Now we're left with 1, 2, 3. Then we have 3 minus 4, which is minus 1. So minus 2 minus 3. Oh, this one disappears as well. That makes our life so much easier. So we have minus x plus 6 minus 6 disappears. And we are left with 2x minus x, which is x. Brilliant. And 3 minus 4 is minus 1. So I must be doing things right. Minus 3 less than or equal to 0. And then I find the critical points. 1 is a solid point. Minus 2, 1, 2, and 3. 2 and 3. 2, 3. And check any number which is greater than 3. So let's say 10 or 1,000,000. 1,000,000 minus 1, it's going to be positive. So positive, negative, positive, negative. There are no surprises here because there are no squares. There's no quadratic terms, so it's just like that. So it's going to be positive, negative, positive, and then square bracket. We square like a right angle here to indicate that this is a including one. So negative, we are interested in the negative values. So we just shade the negative where the function is negative. Okay, if you sketch this function, you will see a similar pattern here. Let's actually do it. So x minus 1, x minus 2, x minus 3. So y is equal to fraction x minus 1, x minus 1, x minus 2, x minus 3. Here we are. Now, you can see that it intersects at point 1. At point 2, it changes sign. At point 2, from positive, it goes straight down to negative. And at point 3, it changes sign again. So between minus infinity and 1, it is negative. Between 1 and 2, it's positive. Between 2 and 3, it's negative. And between 3 and plus infinity, it's positive. I'll just make a screenshot of that. I hope that helps. Like what I'm drawing is a very simplified version of the actual graph. Where the graph intersects, I'm using solid points, and where it just changes sign, I use a circle. Okay, so I hope you can see the resemblance. Like this is that. It's just a different version. Right, and so the answer, and then the beautiful thing about this method is that no matter how many critical points you have, the solution is not harder. Like if you have 20 critical points, it's just a little bit more writing. There's very little thinking involved, less than 0. So it's from minus infinity to 1 inclusive, from 2 to 3 not inclusive. That's it. That's the answer. Any questions? I can wait a minute or two. Maybe comments. How do you like this method? Did you learn something new? Is it useful? I like the method. Nice. Okay. Good to hear. Now here, I can actually see there's a teeny little shortcut here. I don't know if you see it, but you can do it straight away. You can find the common denominator. The common denominator is going to be x minus 5, x minus 4. The problem with this is that when you multiply this out, you're going to have x to the power 5 on the top. And that's going to be very difficult to deal with. Okay. So the method of intervals is just straightforward. It's quite just like, it's simple, easy. But solving inequalities overall is an art. Okay, it's not harder than integration, but it is an art. You have to see some well, you have to use the properties of functions. You have to use whatever it is. And here, what you can see right away is that the first term is actually the same as that. And let's prove that. We have x to the power 4 minus 5x cubed divided by x squared minus 5x and plus 3x minus 25 x squared minus 5x greater or equal than x squared minus 1 over x minus 4. I'm not going to do anything with this side for now. X. But look, if I take x squared out here, I'm just going to do it. I don't want to copy it. X squared. I'm left with x squared minus x, no cube. That's exactly that. Now, am I allowed to simplify this fraction? Well, as long as x is not equal to 0 and x is not equal to 5, I'm allowed to do that. So I just remember this result. Well, it's a denominator. Of course, it's never 0. And I'm left with x squared. And this x squared and this x squared, they go away. So I'm left with, oh, I don't use green. I'm left with 3x minus 25 over. Now, a denominator I always want to factorize. X minus 5 greater or equal than. I'm just going to write these in reverse order just to avoid the minus in front because x cancels. I'm just going to write them in reverse order. 5 over x minus 1 over x minus 4. Common denominator, of course. I'm approaching this problem carefully because what I don't want is cubic terms. I want to avoid cubic terms as much as possible. And at the moment, if I try to do this, I might end up with a cubic term if I don't do it carefully. I mean, if I don't notice that there are common things in the denominator. So it's going to be 3x minus 25, x minus 5, greater or equal. So 5 times that, so it's 5x minus 20 minus x over x minus 4. Now, can I just cancel the x? You can use the mic. Don't be shy. Can I cancel the x here? I mean, left and right, right? I can. Could I do that? X is not 0. So am I allowed to do that? Why not? Of course, x could be negative. So I'm not allowed to do that because what if x is negative? Because then I have to change the sign. So I'm not allowed to do that. So I simplify this. This is just going to be 4x minus 20 over x minus 4. I take everything to the left. So 3x minus 25 over x minus 5 minus. Now I can take 4 out here. So 4x minus 5. It doesn't really help much. X minus 4 greater or equal to 0. And now I find the common denominator. Common denominator, so I'll multiply this by x minus 4. I'll multiply this by x minus 5. And I get 3x squared minus 12x minus 25x plus 100 minus, now x minus 5x minus 5, that's x squared minus 10x plus 25. So very carefully opening the brackets, 4x squared plus 40x minus 20, so plus 25 minus, so minus 100. Now, and on the bottom, I have x minus 4, x minus 5 greater or equal to 0. So what do I have? 100 cancels. 40 minus 25 minus 12. That's 3x. Is it going to be 3x? Is that so? Yeah, it looks like it. 3x minus x squared. Minus x squared over x minus 4, x minus 5 greater or equal to 0. And I take x 3 minus x minus 4, x minus 5. Now, in here, should I cancel the x's? Short answer, no. Don't cancel them. Well, of course, you have this, and you can remember this, but it's very easy to forget about this. Because if you do this, you might forget to exclude 0 from the solutions. So I wouldn't. What do I do is I say, well, what are my critical points? My critical points, is x equals 0, x equals 3, x equals 4, and x equals 5. Now, x occurs twice, okay? We say it is a root of multiplicity 2. What happens? That means, well, x over x is always positive. If x over x exists, it's always positive. So basically, what we're saying is that it changes twice. Sign changes twice at x, because there's 2 x's in the expression. So sign changes twice. Sign changes twice. Okay, and then all we need to do is the usual. So x, now we have 0. Now x cannot be 0. 3. Now 3 is a solid point because it can be equal to 0, because the sign is greater or equal to 0. So 3, 4, excluded, 5, excluded. And now we have to be very careful here. We need the sign here. What is the sign here? And we check a very big number. Let's say 1,000. So 1,000 times 3 minus 1,000. 3 minus 1,000 is a negative. So if x is 1,000, this is positive, this is negative, this is positive, positive, positive. So overall, it's going to be a negative value. So on this interval, we say on this interval, the function is negative. Then the signs change, positive, negative, positive. At 0, the sign does not change because we have x twice, so it changes twice. And now we just draw the line, so negative, negative, positive, negative, square, positive, and positive again. And we are interested in the positive values. So we are interested in those. So x belongs to the interval from -infinity to 0, not included, and from 0 to 3, including, or from 4 to 5, not included. Okay, you can also use this symbol, but I prefer union. So this is a set of values of x. So x belongs to this set of values. It's a union of the set, just like you would write A union B, right? Like in statistics or in probability. Okay. Now in maths, this symbol means and. This symbol means and. This symbol means or. So when you have, this means or. So if you see this, like for example, x greater than 1, x less than 0, x equals 0.5. So this means or. If you put an and here, that would be nonsense because x cannot be greater than 1 and less than 0 and equal to 0.5. So square bracket means or, and figure bracket like this one means and, or it's called a system of inequalities. And there are two of them. Like one is super easy. The other one is well, it's not difficult either. So you can solve the bottom one right away. Solve the bottom one right away. So there are the critical points are 1.5, not including 1.5. 1.5, 1.25, 1.25, and 1.125. 1.125. And then 3, including 3. What about this? It's x minus 1 plus. So it's going to be 1. Another critical point is 1 plus 1 over 2 cube roots of 4. The thing is, we don't know this value. We don't know where to put it. That's the only difficult thing about this question. So 1 plus 1 over 2 cube roots of 4. Okay. Well, we need to compare it to 1.125, 1.1, 1.25, and 1.5. So I'll show you a method. I don't know how useful it is because you can always check it on a calculator. But what if you don't have a calculator? How do you do, or if you are not allowed to use a calculator? So compare and 1.125. Okay, let's compare it with the first number. Well, we assume 1 plus 1 over 2 cube roots of 4 is greater than 1.125. That means that 1 over 2 cube root of 4 is greater than 0.125. Multiply everything by 2. 1 over cube root of 4 is greater than 0.25. Have I made a mistake here? No, I haven't. So multiplied both sides by 2. And now I cube both sides. I get a quarter is greater than 0.25 cubed, which is nonsense, which is not true. Not true. If it's not true, therefore, 1 over 2, 1 plus 2 cube root of 4 is in fact less than 1.125. Oh, that's success, because I don't have to check anything else. That was a good method. That was a good method. I'll just double check this on the calculator. So 1 plus 1, it's 0.25 cubed. Oh, sorry. Which is true, of course. A quarter is bigger than a quarter cubed. Sorry. Okay, I wasn't so lucky. So this is true. So it is greater than 1.125. Okay, let's check 1.25. Compare 1 plus 1 over 2 cube root of 4, and I'll assume is greater than 1.25. 1.25. Then 1 over 2 cube root of 4 is greater than 0.25. 1 over cube root of 4 is greater than 0.5, which is, okay, I need to be very careful here. So 1/4 is greater than 0.5 cubed, which is true. Oh gosh, so I have to do the third one. This is 1.5. Assume 1 plus 1 over 2 cube root of 4 greater than 1.5. Is it 1.5? Yeah. And so 1 over 2 cube root of 4 is greater than 0.5, 1 over cube root of 4 is greater than 1. All right, we're getting somewhere. So 1/4 is greater than 1 cubed, which is not true. Not true. Right. That means that this value, the critical value of x, this one, is between 1.25 and 1.5. And I can check that. 1 plus 1 over 2 cube roots of 4. And it's indeed 1.31. So the critical value is here. So this is 1 plus 1 over 2 cube root of 4. All right, and now I need, I draw the line, not this line. I draw the line. So greater than 0. So check a very positive number, like 100. It will give you a positive. So positive, negative, positive, negative, positive, negative. And we just draw, bam. Oh, so this value is like this, it's solid. Right, down, like this. Okay, and we're interested in the positive values. Interested in the positive values, which are here. Right. Yeah, I think I got it right. On the other hand, there's a second inequality. There's a second inequality here that x has to be greater. So I can only accept those values which are greater than 1, but they're all greater than 1. So what was the point of that? Anyways, I draw 1, and all my values have to be to the right of 1. So I can only accept these, and these, but that's the same thing. And all I need to do is write down the answer. So x belongs to 1.125, 1.25. Maybe I've made a mistake. I'll check and correct. 1 plus 1 over 2 cube root of 4, including, sorry, from 1 plus 2 cube root of 4, including, up to 1.5, and or from 3 to plus infinity, not included. This is the answer. Okay. How much time do we have? Brilliant. So the other questions I have for you, they're quite simple. They just use a slightly different approach. I mean, it's not really a different approach. So you have a modulus here. You can, one approach is to say, okay, as I have taught you before, x modulus x plus 5 is either x minus 5 if x is greater or equal to 5, or it is minus x plus 5 if x is less than 5. And you can solve this inequality using the method of intervals. You will just have two different inequalities. You have x minus 5 times x minus 7 less than 0. So that means from here, this is x minus 5, x minus 7 is less than 0, and x is greater or equal to 5, or it is, well, it will be written like this. It will be written like this or this. So x minus x plus 5, x minus 7 is less than 0, and x is less than 5. Now, this looks way too complicated. It's solvable, but it's way too complicated. You can do it. You can say, okay, so this is less than 0. So very quickly, just sketch 5, 7, and less than 0. That's this region, and x has to be greater or equal to 5. Okay, so x is between x belongs from 5 to 7. What about this one? Well, this one is also going to be 5 and 7, but the size will be different because it's going to be negative, positive, negative. It's going to be like this, and x is less than 5. Oh, so it's in fact this. So x belongs to minus infinity to 5, not including. And the answer will be anything from minus infinity to 5 and from 5 to 7. So two possible solutions. Now, I would do it differently. I would say, well, look at that. This is a positive value. Well, at least it's a non-negative value. Can x be 5? Can x be 5? No, it cannot be, because if x is 5, the whole thing is going to be not true. So x is not equal to 5. And if x is not equal to 5, this is a positive thing. And a positive cannot change the sign. So as long as x is not equal to 5, we can simply say that x minus 7 is less than 0. So this inequality seems difficult, but actually it's not. It's just a positive number times x minus 7. And so x is going to be less than 7 as long as x is not equal to 5. So the solution can be drawn here. So 5, 7. So it's going to be this. So x belongs to minus infinity to 5, or 5 to 7. And that's it. So as long as it is positive, we are allowed to ignore it. And it is positive everywhere except 5. And 5 has to be excluded from the interval because it's not a solution. So x can be any number between minus infinity and 5, and from 5 to 7. A very similar thing here. We have a square root, which is a positive number as long as x is greater or equal to 2. Well, x can only be greater or equal to 2 because otherwise this square root does not exist. What happens at x equals 2? Well, x equals 2 is a solution, in fact. Yeah, we can somewhere in the back of our head, x equals 2 is a solution. Just in case we forget. And here we can say, well, this inequality is equivalent to this, x minus 2 greater or equal to 0, and x minus 5 is greater or equal to 0. So this means that x greater or equal to 2, x greater or equal to 5. And combining the two, we can say that x is greater or equal to 5, of course. But here we lost the 2, and this is where we remember it. Oh, x2 is a solution. So it's always good to check the critical points. So the critical point is oh, sorry, but x can only be greater than 2. Oh yes, x can only be greater than 2, or 2, but 2 including. So x is greater than 5, or x equals 2. I hope that makes sense. Does it make sense? How much sense does it make, guys, on a scale of 0 to 10, please? So if you draw this, you will see that it is either 2 or anything above 5. 5 or above. So 2 or 5. So x belongs to the single value 2. This is a figure bracket. Or anything from 5 including 2 plus infinity. Good. Only 3 10s. The rest are thinking or disconnected. No, still here. Just okay. Now this one is a tiny bit harder, and here the best way to do it is just to consider what do we see in front of us. Well, first we have 2x minus 1 is less than 3. Of course, we have to write that 2x minus 1 has to be greater or equal to 0. It's not possible otherwise. So x is greater or equal to 1/2. So we can only consider the values that are this. But then look, if this is a positive number and this is a positive number, we can square it. Yeah, we can square it, and we have 2x minus 1 is less than a 9. And just got me thinking. So if 1/2 is greater than 1/3, then 1/2 squared is greater than 1/3 squared. Yeah, that's true. Okay, just checking. Could it be otherwise? Yeah, you're pretty safe in saying that. All right, so you have 2x is less than 10, x is less than 5. So the answer is that x belongs from 1/2 to 5, not including. But you can do the same thing using the monotonic approach. You can see this is a monotonic function, and this is a 3. So how does that work? Well, we can say 2x minus 1. So it's 0 when it's a half. So it's going from a half like this. It's a monotonic function, and x equals 3 is here. So 3 is here. 3 is here. So we need to find where they intersect, and this is in fact 5. So anything where it says below 3, where is this function? Where's this function, which is square root of 2x minus 1? Where is this function below 3? And it's below 3 here, from a half to 5. The graphical solutions are, of course, very good. And there are some brilliant examples here in this assignment. So I'll show them to you, some of them to you. Now, problem 11. Problem 11. Well, once again, you can't really use the method of intervals here because, well, yeah, it doesn't really work here, because if you make 0, you don't have a multiplication on the left, you don't have a factorized expression on the left, and you can't really make it factorized on the left. So what you do is, well, you start analyzing. So 3x plus 4 has to be greater or equal to 0. That means x has to be greater or equal minus 4/3. Right. Now, let's look at this. So this is a positive number. This is a positive number. So if this number is negative, that means it's definitely less. So if 2x minus 4 is less than 0, less than 0, then the inequality is true. Inequality is true. It has to be, because if it's a negative value, and this is a positive is always bigger than a negative. So x is less than 2. All right, so x is less than 2, and so the function only exists if this is true. And the right-hand side is definitely smaller than the left-hand side if this is true. That means x belongs from minus 4/3 to 2 is a solution. What if 2x minus 4 is greater or equal to 0? That means x is greater or equal to 2. Then both sides are positive. Then we can square them. Square both sides. As long as they're both positive, you are allowed to square them. And you get 3x plus 4 greater than 2x minus 4. So that's going to be 4x squared minus double the product. So 2 times 4, 8, 16x plus 16. Yeah, looks right. So we got 4x squared minus 19x, really, plus 12 is less than 0. Oh, that doesn't look good. Doesn't look good at all. All right, I'll cheat a little. I'll factorize it using technology so I don't waste time. If it can be factorized. Oh, it can. As a matter of fact, it can be beautifully factorized. So I didn't make a mistake. It's going to be 4x plus minus 3 4x minus 3 and x minus 4. X minus 4 is less than 0. So critical points are 4 and 3/4. And don't forget that we are only considering x is greater than 2. Well, we'll get to that. So this is 3/4. This is 4. And this is a strict inequality. So we're interested in where it's less than 0. So it's positive here, negative here, positive here. And we're interested in this interval. But we have to consider that x is greater than 2. So 2 is here. And we're only allowed to have this. Oh, x is greater than 2. We're only allowed to have this. And the intersection, so x belongs from 2 to 4 is a solution. All right, so we have two groups of solutions, this one and this one. And if we combine the two, we'll see that 2 is, in fact, x equals 2 is a solution. X equals 2 is a solution. We can double check. 3 times 2, 6 plus 4, 10. 10 is greater than 0. Yeah. All right, so we can write down the answer. So x belongs from -4/3 to 4, not including. And oh yeah, yeah, absolutely. Okay, from 4/3 to 4. Yeah, that's about it. And yeah, and it gets to different levels of complication. So let's have a look at a few problems from the assignment. Now this table will be replaced by the lines. Okay, the ones that I've drawn. So you'll see a few examples here. That's all right. Now let's look at this. So the inequality x minus 4, x squared minus 4. Well, here it's just as long as they're both positive, and they are, you can square them and solve it using the method of intervals. But before that, you have to understand which values are possible. So first, you have to solve x minus 4, x squared minus 4 greater or equal to 0. You need to solve this because then you understand which x's are allowed. And then separately, you have to solve x minus 4, x squared minus 4 minus 1 is less than 0. And this is done by method of intervals again. So two separate inequalities, and then you just combine the solutions. You combine the two groups of the solutions where they intersect. Okay. For question 7, you have to use the same reasoning as here, as in the last problem. Very similar reasoning, just a few extra steps. So, and this is a step. This is a step question, so don't expect it to be simple. I did this question just before the before the webinar, and I made a mistake. I got a stray interval which shouldn't be included in the answer. So when I check myself, okay, that makes sense. Once again, the Desmos is a great help. You can always check your answers using Desmos, but you can't really rely on, well, Desmos is not a solution, it's how to check your solution. And what else? I think that's pretty much it. So this one, for example, well, if you have an inequality like this, modulus of x is less than 1. That means x is less than 1 and x is greater than -1. And you just have two separate inequalities. You have, so it breaks down to two separate inequalities, both of which can be solved by the method of intervals. This one's interesting. I myself would say, okay, there are three possibilities. There are three possibilities: positive, 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 negative, and negative, negative. Negative, positive is not possible, because if x minus 1 is negative, x minus 3 cannot be positive. So there are only three possibilities here. And you just have three different, oh, that's an equation. Oh, that makes life easier. Okay, that's an equation. So, so yeah, that's actually why would I delete that? And so these are the problems. You can already start solving them. They would not change, at least not significantly. The problems wouldn't. So just cosmetic changes. So this section, I'll be working on this section today and tomorrow. It's just a bit too messy. And a few more things I'll be doing, and then Alex will add some of his ideas into here, and we'll publish it. Yeah, do you have a question? Please ask.
Hello, sir.
Yeah.
You know, on the topic list, it says in a couple of weeks time we have capacitor. Is it possible if we can do it next week, like capacitor and electrostatics is on the topic list?
It's on the topic list, but the next assignment, the next physics assignment, is going to be is geometric optics again. Okay.
Okay.
We have lenses, and then in the summer we'll do capacitors.
Okay, thank you, Chase.
Right. Okay. You've seen most of the problems for the assignment you have already seen. It's those. So these the questions that are here, but did not get into the final version of the assignment. So everything from this whole section is in assignment number 10. Sorry, is it 10? Oh, 9. Sorry. This is in the assignment number 9, and all the lenses questions are there. So work on those if you haven't already done them. And physics will be published this week. It's actually, physics will probably be published sooner than maths because it's almost ready. Any questions?
Yeah, just out of interest, will COMPOS continue into the next academic year?
Yes, we continue for next year with year 13. Like 95%. Okay, we are because we rely on funding, and we're just in the process of securing the funds for next year. In one way or another, it will continue. It's just probably depending. It depends how many students we can take. So next year it will be open to year 12 and year 13. So please do recommend us, especially if you have friends in year 11. Do recommend us. They should apply and for next year and year 13. We will be. So even those who did not go through year 12 with us will be able to join in year 13. We are likely to recruit 150 year 13 students and 150 year 12 students next year. So there will be more open spaces. So if please do recommend us. All right. Okay, so that's it for today, and wish you luck in the next assignment. We are making assignments shorter-ish as possible. There are 20 questions, but we might even reduce that. But the physics assignment is shorter than normal, so that's good news. So you can focus on exams. You can focus on exams, on your school exams. Okay. All right. Okay, that's the end of the webinar. Thank you for attending. Welcome.